everyone, welcome back to another video on the inTutor. We were previously viewing out on functions and I proposed an exercise that consisted of writing a program that prints out the first 50 prime numbers. What I propose to do now is to break the program into smaller parts, that's functions. So I'm going to first of all be trying to create a function that actually identifies if the number is prime or not. Well, that function is of course going to return an integer and we can call the function numFact. What I'm going to do here is that I'm going to get the function that verifies the number of factors a number has, knowing that prime numbers only have two factors, 1 and itself. And for that case, the parameter in this case is just going to be a certain integer. Let's first of all try out to get the number of factors of a single integer and then we actually view it out. So if you want to check, for example, if 1 is a factor of this x, you will just have to say that if in bracket x percentage 1 is equal to 0. This expression simply tells that if x when divided by 1 gives a remainder 0. So that's just that. Well, but then if we want to know all the factors of a given number, we would have to check out from 1 to that number, knowing that the factor of 7 will range from 1 to 7. The factor of 10 will range from 1 to 10. And well, we haven't declared the I we are using here. So we would call it I. And then we also need an integer that will be counting the number of factors it has. I would call it NF for number of factors. If x divided by I would give 0, then we simply say that NF will increase by 1. The number of factors at the beginning should be 0, and then each time you find a number I within this range that perfectly divides x, we would say that okay, that's a factor, and then we just add it to the number of factors. Then at the end of the day, this particular function should return the number of factors. Probably for that reason, now let's try test the function and see if it works. So here, this function is going to tell us the number of factors that 9 has. If it works properly for about 3 values, then we are going to make use of it along the code itself. Well, the issue is that at the beginning, dividing a number by 0 is somehow a math error. So we're supposed to begin from 1 instead, not from 0. That was an error of mine. So yes, 9 has 3 factors, which is 1, 3, and itself. That makes 3 factors. Let's try another value like let's say 11. So 11 has 2 factors, and if 11 has 2 factors, it therefore means that 11 is a prime number. Trying to print out the prime numbers, the first 50 prime numbers, then we are going to have a for loop that will include those first 50 prime numbers, and then we'll have a number that will be counting the number of prime numbers we have gone so far. We need to create an integer I. Then we say, okay, for I equals to 1 to I being less than, let's say, 1,000. So we could say that the first 50 prime numbers will fall within the range of 1 to 1,000, of course. That's something true. Taking I in an increasing order. This code will not stop until it has attained the figure 1,000. But we are not sure. What we will now have to do is that we would have to verify at the end of this if the counter has already reached the 50th prime number. So we say if counter is equal to 50, then everything stops. And for everything to stop, you just use the break statement. You could just say 51 for it to reach exactly 50. And so, well, these are the first 50 prime numbers printed out using the concept of function. So thanks for watching this video. Hope to see you in the next video for a clearer view of this stuff.